can look into that for me. Then Marisa is saying the chat is disabled. So if someone can look into that for me. Thank you very much, Marisa, for bringing that up. So why do companies need us? And please, if the chat issue is resolved, let me know in the chat. But I'll keep firing away. So that means I might not be able to get your immediate feedback for now, which is cool. So I wanted this to be interactive. I wanted you guys to be telling me while I write it down. I wanted us to edit this slide together, but it's cool. This still works. So why do companies need us? First of all, data in its raw form is useless. For those of us who did the DA program, if you remember, if they just gave you the margin Dogo spreadsheet, it will make sense to you. You had to work on it. You had to do something. You have to do some work on the data set. And then you discovered corruption, you discovered underserved areas, you discovered so many things. So data in its raw form is useless. Just like crude oil is valuable, but messy. So we have to build pipes or pipelines to process this data. So I want you to picture the image of an oil rig versus a gas pump. At the oil rig, data is messy, but at the gas pump, the data is already refined. And like I said in the what you call it, at the intro session, I said something. I said, without us, all the other data fields can't do anything. So there's this running joke where we say, be nice to your data engineer, because we ingest the data, transform it, and load it. Load it for the data analysts, the data scientists, those doing machine learning. So I hope we're still together. I hope I'm making sense. If the chat feature is now enabled, I would love to know. Is the chat feature now enabled? Nozipo, are you ADP?
Yes, I'm a DP. Okay, I will look on that.
All right, cool. Boys, cool. We're still together. So I know the chat feature is not enabled, but are your emojis working? If emojis are working, please let me know in the Q&A if they are working or not, so that I'm not just droning on and then we are not following. Are your emojis working? If your emojis are working, let me see them. I don't know, can anyone see any of the emojis before the chat is set up? Okay, the emojis are working, but I can't see them, but that's cool. I want to check, can you see the emojis? All right. So, yeah, where was I? Why do companies need us? Yes, we help to refine the messy data. All right, thank you so much, Tim Tupe, for your feedback. Awesome, awesome. It seems at the end of the day, maybe the Q&A will be, I'll be using to get feedback, but that's cool. All right, so I know it's a Q&A, but maybe I'll be the one asking the questions in the Q&A now. So we as DE people are builders versus the other data fields where the data scientists are scientists. After the picture, the engineer building a race car and the scientist driving it. Key term, we create infrastructure, not insights. But more often than not, you find out when you're pushing your CV or when you're looking at job descriptions, some companies, yes, to save costs, they may want to combine DE and DS or DE and ML. So it happens. So that's why a lot of ways you see some similarities between what we are doing and what maybe ML is doing or what DS is doing. It's just so that you are ready for the work environment. So I want to ask a question now in this Q&A. For example, if a dashboard breaks, who fixes it? A dashboard breaks, the information is not being loaded. I know we all know what dashboards are. Who fixes it? You load a dashboard. Let me see your answers in the Q&A. You go on the dashboard and then the values are not even coming on. Who fixes it? Who are we going to call on speed dial? Thank you, Marise. The data engineer. Now,
Sorry, Coyote, sorry to interrupt you.
all right.
At this point, since the session is running, apologies, guys. The settings for letting people speak on the chat is disabled since the session is running, so they can use the Q&A.
Okay, cool. Thank you very much, Nozipa. Thank you. All right. So, yeah, where was I? So, what if a prediction is wrong? We looked at the dashboard and the prediction. We looked at the dashboard from data set or from data warehouse. Data scientists did, or the data analysts did some calculations, but the prediction was wrong. If they made a particular projection on the profit a company was going to make, or maybe the amount of food an aid group was going to need, but it was wrong. Who do we call? Who fixes it? Let me know in the Q&A. Let me know. Who fixes that? Wrong prediction. Who fixes our wrong prediction? I'm waiting. Who fixes our wrong prediction? I want it to be as interactive as possible so that we grasp the concepts, because at a particular stage, we'll be on cruise mode. I want us all together. Who fixes wrong predictions? Does anybody have the answer? Take a guess. Be bold, do hard things. If the data engineer fixes a dashboard that breaks, who is responsible for a prediction that is wrong? Or should I call names? I can write it out in the Q&A. All right. Save our time. The answer would be our data scientist or our data analyst. So it's just, we're just telling you how the roles differ. I hope we're together. I hope it's still making sense. So this is the key reason why companies need us. We take raw, messy data and transform it into something that is valuable, something that is useful, and other departments can use. I'm seeing Cheese, your hand is raised. Can you please write or say what you want to say in the Q&A? Change the chat is disabled. Awesome. So I hope we're beginning to see our value now, how we provide the foundation for the data fields. So you may begin to wonder, because going forward, or in a way we've been coming from, we've just been calling data. The data sets we've been receiving, we've just been calling them data. But in DE, we'll be referring to it, we'll be referring to data, we'll not just say data, we'll say big data. We'll be saying big data. And why? It's because of big data that we need data engineers. After all, we've been working with data sets, 60,000 records like Margin Dogo, the farm, for those of us who did Python, the farm data set, the IMDb data set. we are talking in big data, as you can see from this diagram, I hope you can begin to see when we're talking of in terms of volume, velocity, and variety. The three V's of big data. There are five. We're focusing on three today. So when we talk about volume, you can see the sheer scale of data created when you search on Google. 8.5 billion searches a day. At least this was based on 2003, 23, 2025. On Meta, almost 4 petabytes of posts, photos, and videos hit its warehouse daily. Amazon, our S3 bucket, stores over 350 trillion objects for customers. If we gave you an integrated project with 350 million trillion objects, how would you feel? I tell you, use your spreadsheet or your MySQL data, how would you feel in particular? Without having, without knowing anything about data engineering, I can tell you, you won't have a really nice time. That is, you can even complete the task. And let's look at velocity. The speed in which data arrives and must be acted on. As data engineer, you find out that if you are working for a credit or debit card company, you have to detect fraud in real time. Your pipeline must not break. You can see Visa has to detect fraud in 1 millisecond, handling 65,000 messages per second. Twitter looks at 500 million daily posts. Or the stock market, where 1 second is even a lifetime. All right. Woo! Our chat feature has been resolved. So yeah, congratulations, everyone. Let's congratulate ourselves. We are good to go. Awesome. Thank you, Nozipo. All right, all right. You guys are awesome. Cool. Oh, it's Samantha. Okay, thank you, Samantha. Awesome, awesome. Next, we go to variety. Up until now, you guys have been working with tables, rows, and columns. Now, there are a lot of other formats apart from your rows and columns. Thank you so much, Samantha. For example, building a pipeline for Netflix recommendation, you have to work with artwork, videos, recordings, TikTok, the same thing with videos, PayPal. You have to study. In fact, I don't know if any of you have heard of Neuralink. What do you call it? Elon Musk's company called Neuralink. Let me know in chat. Have any of you heard of that company where they put brain implants? Yep. Cool, cool, cool. So, reading up, I discovered that every human, your brain wave is unique. So you find out where you have to store, you have to have a database of everybody's unique brain wave. I tell you, your Google Sheets can't handle that. Or do you think Google Sheets can handle that? Let me know in the chat if you feel Google Sheets can handle that. I hope I'm still audible, Shegun. All right. Awesome. Okay. So we can see that these three V's pose three big challenges to handling big data. We need unique tools. We need a unique way of thinking about how we go about processing data, storing data, moving data, and even digesting it. We can no longer think in the old way because it will not suffice. Are we still together, people? So let's have a little thought experiment. Maybe to drop this. Give me an example of velocity data you generated today. We all generated all these three V's. But I just want for velocity. Who can tell me in the chat? And it's the thing is, I'm asking questions because these concepts, once you get them, by the time we are building pipelines and writing code, you would have to keep them at the back of your mind, especially when you want to write efficient code or know the tools you are going to use. I hope we are still together, people. So yeah, give me an example of velocity data you generated today before this session. Let's go. I'm waiting. I'm waiting. I'm looking at the chat. Thank you. Oh, oh. For those of you who use Bolt or Uber today, so you can see a data engineer somewhere is maintaining the pipeline for your WhatsApp messages, for Instagram feeds, in some cases, so that they can sell ads to you, so they can recommend. I don't know whether any of you saw that thing where they said, I don't know if you see that thing on Instagram where they say someone you may know, and someone said that is so that section for someone you may know are people who have been looking at your profile or are connected to you in some way. There's this running joke where they said, if you see someone you may know and you are dating and it's of it's of the same sex, maybe like that might be the person your partner is cheating with, or your partner is DMing. But I'm not giving credence to that. It's a rumor, though. We don't know how the algorithm works behind. Yes, yes. So it's a pipeline. It's someone like you and me somewhere who decided to learn data engineering, got experience that is maintaining all that. So I hope we're going to have, along the line, we're going to have a session called data engineering in the real world. And I hope we do have one of the same data engineer who did the last session, one of our two data engineers at ALX, to come and talk to us about some things. So you see that we all started from somewhere. And once the most important thing, once you grab the concepts, you can apply it using any tool that you need to use. I hope we are still together, people. So I know we've hammered down velocity, but now because we have been used to SQL data, and I don't want us to, or structured data, I don't want us to get some hang-ups. I want us to clarify differences between these two going forward. Because we know DE, if I'm trying to oversimplify it, we're focusing on building pipelines, data pipelines. What kind of data pipelines? Why is it now a pipeline? Why can't I just go for my Google Sheets? It's because we are dealing with all kinds of data, not just the usual structured data, but even unstructured data. And I give an example. I said, but I have to store a database that stores brainwave information. So I know we all remember our structured data, our SQL relational tables with fixed schema, MySQL, our syntax. Meta uses it too. In some cases, maybe and for social graphics, Shopify, for checkouts, Instagram to store likes and follows. And then our structured data uses SQL and NoSQL DBMS like MongoDB, Cassandra, Redis, and DynamoDB. Syntax to query or make queries on those databases are different. Netflix, you see how easy to log billions of viewing events a day. Amazon having over 146 million requests, and Discord keeping trillions of chat messages on ScyllaDB. And we can see for SQL or structured relational database, they are best for payments, inventory, and reporting. And for unstructured database, they are best for caching, catalogs, for charts, for feeds, for in gaming, what do we call it again? So many other non-conventional examples of how we store our data. I hope we're still together. I hope I'm still audible. Are we still together? Please let me know in the chat.
Yes, you're still very much audible.
All right, all right, all right. Thank you very much, cool people. So let's say I want to store a user profile, name and email. What kind of database would I use? Or what kind of DBMS would I use? Let me know in the chat. All right, all right. Okay. Now, thank you very much, Audrey. Now, what if I want to store their click logs? How many times they've clicked on something? Their click logs. What kind of DBMS should I use? Yes, NoSQL. When I talk about the let's say we have 5,000 click logs, the click behavior, we store it in our NoSQL DBMS. So we're together. We're together. I like that we're understanding these basic concepts, the fundamentals. So let's now even look at the pipeline, the core of the entire matter, the blueprint, the entire topic. We find out that as a data engineer, more often than not, you'll be performing ETL or ELT, depending on the use case. But for this particular piece, for this particular course, we will be focusing on ETL, not ELT. And in summary, what you'll be doing is to extract data, ingest it from whatever source. The tools you are going to learn how to use will teach you if it's coming in batch or in stream, if it's a lot, if it's little, what to do, how to go about that. So you have to do that efficiently. That's why you see where we mentioned airflow, so that we don't waste resources. But because this is big data, I don't know if you guys remember when we're doing Power BI and we're saying, or even SQL, there's some query at a particular stage, towards the end of the SQL course, we will tell you, don't use select all, because the production environment, it will cost you a lot of money and you're wasting resources. And then to load it into a warehouse or a data lake. So if you've not gotten anything at all, you should keep in mind that as a data engineer, your core function is data pipeline. But now you're working with big data. So you can't treat it the way, or handle it the way you've been handling data sets or databases of before, or smaller databases. No, you're in the big leagues now. So going forward, have it as a data engineer, I build pipelines. And for this course, extraction, transformation, and loading, I'll be learning the tools that will enable us to do this. But the key thing is that you find out that even if it's if you focus on extraction, we can just teach extraction, not just extraction. If we are teaching streaming extraction, that can take us the entire year. If we want to just learn streaming, not even batch, but streaming, the streaming aspect of ingesting or extracting data, we can do it for the rest of the year. That's what I'm saying. Have this at the back of your mind. So whenever we're using tools, whenever we're doing anything, try and relate it to these concepts. Or if you feel like you are getting lost, even though you can always ask questions, especially when we start building pipelines and orchestrating data. So as you can see, this is the blueprint. We get data from different sources. It could be an app database, a SaaS API, event stream from logs, from files. We extract, we are going to pull out the raw data. Like I said, either through batching or streaming. If you're using Kafka, then that means it's streaming. I can see Kafka can handle 7 trillion messages a day. They gave the example of LinkedIn, or 5 trillion or airbytes, but we'll be focusing on Kafka. And then we will transform this data because it's messy. We need, like I mentioned at the start of this session, we need to get value from it. So some people use DBT, we'll be using Spark, we'll be using Airflow to orchestrate every step. And then we keep it somewhere where other teams can use, that makes us the foundation for all the data programs and data departments in any institution. It could be in a data warehouse or a lake house, using different cloud services like Snowflake, BigQuery, or Databricks. Are we still together, people? And then once it's there, those who want to build dashboards, those who want to carry out machine learning, those who want to carry out data analytics, can take it out. And so, as you can see, we look at reward pipelines like the one Netflix does. Netflix uses Kafka, Flink, and Iceberg before using Kafka. Trillions of events land in Lakehouse daily. Spotify, for beta flow, BigQuery. User events, per royalties, and WAP. So these are your favorite artists gets paid. This is the pipeline behind the payment for your favorite artists. And then Airbnb uses Kafka, Spark, and Airflow. Kafka to ingest the data, Spark to process it, and Airflow to orchestrate. I can see here that Airflow DAGs run 150,000 tasks a day, over 150,000 tasks a day. Don't worry about DAGs. It just means directed acyclic graphs. I would explain further when we get there. It's just Airflow is just help with orchestration. It means after this, do this, after this, do this. I'm oversimplifying. But if you ever get lost, just know Airflow is doctor. It says you go here, you don't go here. Has this been done? Okay, then do this. And then you use Python to let Airflow know this is how you go about it. And on Airflow, it shows up as your DAG. So you use your Python to create your DAG. And before I go any further, I hope we have been practicing our Python and SQL. Have we? If we have not, I want to kindly remind us to please keep practicing our Python and SQL. And even if you are struggling with it, don't worry, there's an antidote on the course. I will show you the antidote if you are struggling with code, especially code syntax. But like we said, even in the age now that you can write code, it's still good you know the basics. So I'll still crave your endurance. I want you to still keep practicing these programming languages the old school way, the hardcore way, so that you don't get lost. In summary, so that you can easily debug, so that you get exactly what you want. So please keep practicing your Python and your SQL, as Python will be the main program language we would use for this course. I'm really excited because even though some people now might be wondering, I remember when I joined the Explore to study data engineering, when I got the admission, I data engineering first year, or some people in the course have Google data engineering even after they got accepted to sign up for enroll for the course. But the good thing is, last week we had our showcase and cohort 10 built amazing project. Someone built a data pipeline for the restaurants in Nairobi. Another person did another one for the cryptocurrency prices. It was beautiful. I was so happy. I almost shed tears of joy because I knew how we were. In fact, some even use tools that we not teach, like Grafana, because I knew how we were when we started. So I hope this blueprint has encouraged you, has motivated you. And I know that by the time it gets to the showcase, you guys will have a lot of projects for me to judge. Don't forget to also include them to your LinkedIn. Don't forget to go through the slides and just keep your mind as a data engineer. You are building pipelines, but there are so many concepts you have to grasp. Because like I said in the intro, you can build a pipeline, your code is correct, but the pipeline is a failure. Everything is working, but the pipeline is a failure. And you get to see why. So we're going to go to the nitty-gritty of some things. And the good thing is you've done courses like DA and Python. So some concepts will be easier for you to digest and we can flow smoothly. Are we still together, people? Do we have a basic understanding of what we data engineers do now, what a pipeline is? All right, Maurice or Marise, I hope I'm pronouncing it correctly. I like the double S you put. Yeah, you guys are awesome. You guys are awesome. So this is a gentle intro to what we'll be doing. Please do not forget to go through the content, study, grasp the concept so that the code does not confuse you, so that you understand what we are doing. Even if you come in the middle of any session, you just know, okay, this is what is happening. All right. So I normally love to give more than you paid for, and I have this session called Beyond the Pipeline. Yes, we know we build pipelines, but there are so many things attached to it. Not just look at this Instagram post from Moist talking about the Cadillac Championship that was, created to mirror the motion of a golfer's swing. I brought this up because, as you can see this comment here, it says, there's a human process in creativity that cannot be prompted away. I hope we're still together. In the age of LLMs, Gen AI, how you function in tech is very different from in the days of old. In fact, we'll be using it even during this course, especially when we're using Docker. When we have issues, to save time, we just tell Gordon, that is Docker's AI. Please look for the error in our code, fix it, and let's get this pipeline moving. But the human mind will always be relevant. That's why I keep telling you to practice your Python, you practice your SQL, go to the course content. Because if your mind is empty, you can't even prompt properly. Are we still together? You can't even have ideas to prompt. So this is just what I want us to ingest and think about, prepare our minds, keep practicing our SQL and Python, and begin to understand these concepts and how we're going to, use it in practice. I hope we're still together, people. All right. So this brings us to the end of today's session. I hope it was not just short but sweet. Let me go and check the Q&A. If you have any questions, there are no questions, but please kindly ask your questions. I'll be using the poll now for this session. So you let me know how you guys feel. Okay. All right. So the poll is out. Can you please fill it? And let's get your feedback. Don't forget, if you're having any issues, ask the ALX data program team on eHub, on FreshDesk, especially if you're having issues logging into AnswerBase. And also on AnswerBase, you can just take a screenshot and put your question on AnswerBase, and we will be there to help you out. Don't forget, you have your first submission next week, Monday, on the 20th, and it's called your database MCQ. Don't forget, we are all finishing this course, and you are not alone in the community. Your alumni, volunteer mentors are there to support you. Post your wins. They are your CV too. Don't forget. So, I'm wishing you guys all the best. See you guys next week.
sohlukaniswa ukufa noma bathakathi besilima